Hey guys, welcome to another video. This one's on decimals. So, what are decimals? When we're usually dealing with numbers, we have whole numbers 1, 2, 3, 4, 5. But sometimes we don't have whole numbers. Maybe like a price. They always give you 12.99. That's an example of a decimal. It's not a full number. There's a fractional bit, but we're representing it in our number system using what's called a decimal point. That little point right there. So how do you interpret decimal numbers? How do you put a hold on them? Because with normal numbers, like let's say 12, that's 110. It's 1 times 10 plus 2 times 1, right? So then how does it work for decimals? Well, it works the exact same way. The same way that, we have units here, tens here, hundreds, thousands. When we're going to the right, take like 420.69. We'll have our units, tens, hundredths. When we're going to the right, this becomes our tenths and our hundredths. And going on, you just keep on dividing by 10 as you go. So 1 divided by 10 is just 1 over 10. A tenth divided by 10 is a hundredth, 1 over 100. And when you want to go to the left, you multiply by 10. So a unit times 10 is just a 10, and then 10 times 10 is just 100. So just knowing that, just try fully writing out like 100.3, 212.44, 0.33, 0.5. And when you usually say these out loud, you wouldn't say 212.44 because 44 implies something else. 44, just from our English vernacular or whatever, 44 represents 4 times 10 plus 4. That 40, 30, 20. You're talking about whole numbers basically. You're talking about this side of the decimal point. So when you come here, you just say 4, 4. You just read out the digits as they come. 0.33, 0.5. So yeah, then we can come to comparing decimals. And in most cases, when we're comparing whole numbers, more digits essentially means bigger number. Like if I'm comparing 1, 0, 0, 2, 3, 4, and I'm comparing 1, I'm obviously going to say this one's bigger. That's more digits. Like I'm not even going to think about it. 1 is just the 1. This guy's like 4 in the 1 place, 3 in the tens place, 2 in the hundredths. Well, there's zeros in the thousands and 10,000s, but then there's 1 in the 100,000s. Just a huge number. But when we're working with decimals, when we're going to the right, remember as we go to the right, we're dividing by 10. We're dividing the place value by 10. So any place value to the right is actually smaller than any one to the left. So this 9 hundredths, like 9 hundredths, you can just see what I'm doing over there. 9 hundredths is way smaller than 6 tenths. Right? You can convert them to the same just to see that. If I want to convert 10 to 100, I just multiply by 10 over here, right? And then whatever I do to the bottom, I have to do to the top, right? And this is 60 over 100 versus 9 over 100. And you can already see which one's bigger. But just by using our basic, more digits means bigger number. Comparing the top, 60 is way larger than 9, right? So when you see something like 0.006799799, comparing it to 0.1, you might think more digits, bigger number, but then you realize that all the numbers, let's just see, this is the units place, right? This would be the tenths place. This would be the hundredths. This is the this is the units, tenths, hundredths, thousands. 1,000th divided by 10 would be our 10,000ths, and 100,000ths. And then you see just the numbers get small, the place values get smaller and smaller, while 0.1 is just 1/10, while these guys have 0/10ths, 0/100ths. They're just in a different league of being small. And you would conclude that 0.1 is actually larger than this, right? So the 0 in the 10th position, suppose this comes 1000th position, 1 in the 10th position. Yeah, so that's just, if you just work through, if you just think about it, like where the place values are, what value this is, 0.1 is way larger than that, right? So what happens when you multiply by 10? So I mean, there has to be a correlation, because I said when you want to move up a place value, you multiply by 10. When you want to move down a place value, you have to divide by 10. So, I mean, there should be something underlying there, multiplying by 10, dividing by 10. So if you look at this 1.09, if you multiply it by 10, you can do this however you want to do. You can do it in your head. If you already know this, you can do it with a calculator. You get 10.9. which looks awfully familiar to 1.09. And you can just notice that the decimal point just bloop, jump to the right, right? But why? Well, it comes back to place values. This 1 is in the 1's position, this is 0 is in the 1 over 10 position, and this 9 is in the 1 over 100. So if I write out the number in full, it's 1 plus 0 over 10 plus 9 times 1 over 100, or 9 over 100. So now if I multiply this whole thing times 10, I'm not sure if you know how to expand brackets yet, but it's essentially just me taking this 10, multiplying 1 by 10, multiplying 0 over 10 by 10, multiplying 9 over 100 times 10. So what happens? Then you're going to get 10, because 1 times 10, that's 10, plus 0 over 10 times 10 is just 0, plus 9 over 100 times 10, which would be 9 over 10. And if we write that out, that's 10.9. So you can see that the decimal point just moved 1 over to the right, because you basically promoted this 900th to a 9/10ths. You promoted this 0/10ths to a 0. I mean, I should write a 0 times 1 over there, but that's just still 0. You've promoted from 1/10th, from 0/10ths to 0 units, and you promoted this 1 unit to a 10. So I mean, that's essentially why it moves, but I mean, you can just shortcut and just remember, if I'm multiplying by 10, I move the decimal point to the right, and this increases the value of your number, right? And if I'm dividing by 10, it's just the same process backwards. If I have 10, or let me just write it out. If I have 1 times 10 plus 0 times 1 plus 9 times 1 over 10, and then I take this whole expression and I divide each thing by 10, right? 10 divided by 10, that just gives me, so I'm just gonna go once again, each thing, separated by a plus. I'm just gonna perform this operation on. So That's 1 times 10 divided by 10, that's just 1, plus 0 divided by 10. 0 times 1 divided by 10, that's 0. But I'm just gonna, 0 divided by 10, 0 divided by 10. Plus 9 over 10 divided by 10, that's 9 over 10 times 10, which is just 100. And we just got back here. And if you write that out, that's just 1.0 in the tenths place, and then 9 in the hundredths. 1.09. And if you just look at it, the decimal point just shifted over to the left and made our number smaller, because we're dividing. And when you divide by like 10, you have to make things smaller. You're making things smaller, right? When you divide, you make things smaller. When you multiply, you make things bigger. So that's how you just remember that, if you ever get confused, like, am I moving the decimal point to the left or to the right? Just try it out. Like, if I was lost and I had, like, I don't know, we can just look at an example. Like, if I had this 20 divided by 10, and I was like, do I move it to the left or to the right? If you move it to the left, you're gonna get 2.0. If you move it to the right, you're gonna get 200. And what makes more sense? Dividing by 10 gives you 200, and dividing 20 by 10 gives you 2, and that's the one that makes more sense, right? So yeah, it was just a short little thing just to get you into decimals. So I can just do these with you real quick. Just left out some hints. If you see a number like 1,000, don't be intimidated. That's just 10 times 10 times 10. So if I'm dividing by 1,000, I'm dividing by 10, then I'm dividing by 10, then I'm dividing by 10, which means that I'm moving the decimal point. To the left, then to the left, then to the left, 3 times, right? So yeah, 20 divided by 10. If we just look at 20.0, I just did it already, but you're dividing by 10. So I'll move this guy over to the left 1 time, because you're just dividing by 1/10, which just gives me 2. Then 0.005 times 1,000. 0.005. Now 1,000, remember I just said you can just break it up into 10 times 10 times 10. Generally, you can just count the number of zeros, so 1, 2, 3. Or, I move it up once, that's me multiplying by 10. Then I move it up again, that's me multiplying by another 10. Then I move it up again, that's me multiplying by that third 10. So my answer should be 5.0. Or you can just look at the number of zeros in your number. There's 1, 2, 3. So I just move it 1, 2, 3. And you get your answer. 90.45 divided by 100. I'll let you just do that in your head real quick. It should be pretty simple. Then 10 divided by 20. 10 divided by 20. Now, I know, man. I've been there too, man. You might just wanna, I don't know, let's just 10.00. You might just wanna, maybe add some zeros in here. You might just be tempted to go 1, 2, because you're dividing by 2 tens, aren't you? But no, that's wrong, right? If you want to just break it up to just see why, you're dividing by 2 times 10, which is very different from here. Where you could break it up into 10 times 10 times 10. You're dividing by 2 times 10. So, I mean, yeah, so you're dividing by a 10, so you can move the decimal point to the left. But now you're still left with 1 divided by 2, right? And if you know this answer, that's just the 0.5. or 1 over 2, however you want to represent it.